I'm Alan Brown, the Business Development Manager for Print Electronics at Nagase ChemteX America. And today we're going to talk a little bit about conductive inks and selecting conductive inks dependent on the application and properties required. I thought I'd do things a little bit different than what we've done in the past because many times customers get in situations where they just have an ink on the shelf and they just pick that ink and then it meets 9 to 10 properties. That 10th property is really critical, but because they haven't spoken with an ink manufacturer, it's too late to change something at that point. So, like I said, I'll give a quick introduction on the company. We'll talk about the applications, conductive inks and dielectrics, and then selecting an ink combination based on the application and properties required. So a quick history of Nagase ChemteX America. We started as Engineer Material Systems, which we were a manufacturer of adhesives for electronics, which includes, solar, wind, automotive, lighting, print electronics, and then general industrial markets. We were founded in 1993 and began manufacturing in 1995. We began manufacturing conductive ink shortly thereafter in 2003. In 2012, we were acquired by the Nagase Group, which is a $9 billion Japanese trading company. New facility in 2015, expanded to what you see there on the right in 2018, which is about 10,000 square meters, and then formally changed our name, which was confusing to a lot of people, in 2021 to Nagase ChemteX America. We've got the automotive quality standard IATF and then also ISO 9001. As far as Nagase ChemteX is concerned, there's 3 different locations worldwide. We are based in Ohio, in Columbus. We have 13 R&D staff and 5 QC staff. There's a location in Japan and a location in China. None of these locations make the same materials. We all do something unique. However, if a catastrophe were to happen, we can obviously switch manufacturing to one of the other facilities to keep everybody up and running. Jumping into the applications. As far as print electronics are concerned and the screen printed inks, we primarily participate on the left hand of the pie chart. We manufacture inks for heaters, photovoltaics, touch panels, antennas, and RFID. We do biosensors, primarily for glucose sensing. We do inks for force sensors. We do inks for flexible circuits, whether that be on paper or some other type of fabric. And you know, on the following slides, I'll get into more details on these applications and selecting the right inks. Talking about, you know, the different types of inks and dielectrics that are manufactured. Conductive inks would include silver. Those are typically less than 20 milliohms per square per 25.4 micron. Carbon inks, less than 50 ohms per square per 25.4 micron. And then other metals, whether that be nickel, silver, copper, silver chloride, those range from 25 milliohms per square per 25.4 micron to 10 ohms per square per 25.4 microns. The processing of a conductive ink on the left, that's an example of what a conductive ink would look like after it's printed in the wet form. The silver particles in this example disperse in a resin solvent matrix. Upon the application of heat, the solvent's removed. The conductive particles packed together during this heating process, creating your electrical pathways. The conductive flake or particle ratio is balanced in the inks in order to optimize resistivity, adhesion, and also cost. The dielectric inks, at least as far as Nagase ChemteX America is concerned, and I'm going to start referring to, I don't want to say that all day long, so we are also known as NCU. UV curable, 100% solids,